Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about Intel's messed up. So what the hell is happening? You must be seeing a lot of news about it, so let's figure it out what the hell happened. So what exactly is the issue? Well, issue is something is really wrong, meaning we have crossed the threshold of where it's like, maybe this happened, maybe that happened, if this, then that. No, we crossed that threshold. We have crossed that. Investigations have been done. Enough RMAs have been filed that we know for a fact something is wrong in Intel. Now, what does it affect? Intel is a huge company and even grander portfolio. So what does it affect? It affects specifically 13th gen and 14th gen flagship processors, meaning if you are talking about 14900K or basically that's associated ecosystem, meaning if you are talking about i9 and very high end in the i9, yeah, that's what we are talking about. And not only in one generation, but in two generations, 13th and 14th. So that's a big thing because again, two generation independently launched generation getting affected, that's a bad sign. That happened. Now, how did this problem start? Well, the problem started with crashes. Now, this has been going on for few months at this point in time. So initially, this error was coming that the moment players were like, again, you bought a flagship system, you're like, I'm going to do gaming. You bought a flagship GPU, I'm going to do awesome gaming, DirectX 12 gaming. You launch up DirectX 12, ping, it fails. DirectX 12 memory error. Now, Intel initially blamed it on NVIDIA. NVIDIA did its investigation and NVIDIA was like, NVIDIA blames Intel for GPU VRAM error, tells GeForce Gamer experiencing 13th and 14th gen instabilities, contact Intel support. Now, like, wait a minute, how the heck that happened? Well, you have to understand, processor is kind of isolated from everything. It actually talks to its own VRAM. Now, there is a lot of sub-processes going on. Again, people who study this only can explain it. I can just talk about surface level. Now, there is a process known as basically uncompressing. You take the compressed file, you decompress it. That stuff takes a lot of oomph, that of crunch. And Intel was pooping the bed in that part. So even though you had giant 4080 graphics card or something like that, the graphics card is good, the VRAM is good, the game is good. It's just that when it had to go there and decompress, it was like boing, bad message. Now, this is how it started, and then more and more system happened, even more things happened, and then even more things happened. Even more companies came forward from Unreal to other companies. It's like, bro, something is off here. Enough people were getting issued. Now, first time it was like, oh, GPU fault. Then it was like, okay, motherboard fault. Intel blamed everybody. We have crossed that threshold that it is only basically Intel only. Now you're like, how can we isolate all other variable? Well, first very simple thing is AMD exists and AMD is not facing that. That's one thing. Now you may be like, mathematically speaking, one valid point would be there is not enough sales volume in AMD. While AMD is growing, it's still in growing. Majority of computers are still Intel based. So that could skew the results. That's a valid point. Awesome point. Great. I respect you if you figured it out on your own. That can happen. But here's the servers are also suffering from this. Servers have a lot of Intel, and again, they were conservatively run by validated hardware, no overclocking, everything to the letter, to the specification of Intel. And again, you have no Windows there, you have Linux, and Linux kernel system is as rock solid as it can get. It has been running for decades in some scenario. We know that works. So removing all the variables, then also we are reaching a point where it's like, hey, yeah, Intel is throwing up error. That has isolated to a point where it's not like, oh, DRAMs are throwing up error, oh, GPU is throwing error, oh, motherboards are overcooking the CPU. No, everybody nailed down to this exact point that Intel messed up royally. So this is the issue. Let that be very clear. This is real, this is here, and people are suffering from either instability to outright CPU going poof. Yes, that has also happened, unfortunately, meaning you're gonna have poof to CPU. So what are the causes? Now let this be very clear. When I'm making this video, it's still under investigation. When you are watching it, there is a tiny possibility that 5 minutes later, Intel releases what exactly happened. But as of now, we are still, everybody is investigating it. Nobody has precise exactly, oh, this is what went wrong. However, there are some key insights that give us a context what could have happened. So first one is manufacturing defect. Now be mindful, Intel is one of the few companies still that has their own fabrication facilities, meaning they can make their own silicon. Almost every other company has to go to either companies like Samsung, companies like TSMC, or other companies like that. There are others, but they are much smaller. That's why I'm not able to remember their name. But Intel is one of the few that is like, bro, I got this. They make their own silicon in-house. So again, that comes with pros and cons. You could mess up. So There's a tiny problem, things happen, and be mindful. It's not like, oh, Samsung never suffered from this, or TSMC never suffered. They have a giant list of these things. These things do happen. So that's one option. Second option is, most likely what's causing the failure is power issue relating to voltage. Now, how the heck that is happening? Well, reality is all this silicon that you see, this billion trillion dollar system, and yes, this is what cost billions or trillions of dollars to actually make. These things are so complex that you cannot actually measure it, meaning you may think, okay, 60 degrees Celsius, here's the deal. 60 degrees Celsius means nothing. It's just an average of this area, which you are hoping is accurate. Now, like, why you are hoping it's accurate? You have the sensor here. Yeah, ask any engineer who designs the silicon, they will flat out tell you silicon is not a good conductor. So this area literally could be cooking to 120 degrees Celsius, and this area temperature sensor would be reading 58 degrees Celsius or 80 degrees Celsius. That's why we literally have sensors in every core block, at least. So one core block, one, two, we will have to put that. And you must have noticed that many times if one core boosts up, they could goes up so high in temperature. It's like 90 degree, 98 degrees Celsius, while other cores could be as low as 60 on a normal liquid cooling system or even a big air cooling system. How the heck that happens? Because you have to understand, in all dimension, it's not same what you call transfer velocity, meaning heat energy from one to another cannot travel as easily. It's not a copper block. Silicon is not a good conductor. So you have a sensor here, and again, where do you put the sensor? Companies have to take a guess, because again, designing a sensor, putting a sensor there, having the op amps required to read the data out of it, all of that takes away from actual silicon real estate. So if all this is happening here, you cannot be like, okay, I'm going to put a sensor grid, hundreds of sensors there. You would love to, engineers will love to, and that will give you precise control of it, but that will A, either make it too expensive, B, it will be wasteful, meaning you are wasting actual silicon switches that could be used for actual compute to just like, hey, measure the temperature. So there is always a balance. So consequences, if you messed up that part, where basically where are you putting the sensors, you could literally have a CPU that is reporting me good, mean under 99 degrees Celsius, where it's supposed to trigger shutdown, it could be cooking to almost 120 degrees Celsius. That's why you have to understand. So the voltage regulation algorithm is running here. It's talking to the stuff, it's talking to the motherboard, and based on its own temperature, is saying, give me more power, I can take this. Now, what if it cannot actually take this? If you messed up that algorithm and it's taking more power while it cannot digest it, boom. So that's happening. So that's why flat out the first suspect is the fail safes are not working, meaning it's going into a place where it should not be allowed to go. We are not in 2000s anymore. Back in those days, if you had a CPU, it removed the cooler, it will burn. Now we no longer have that, because again, CPU will try to run and it's like all the sensors like bro, alert, 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 and system will be like, okay, shutting down. You should not be allowed to fry a CPU. And that's why in the early 2010s, overclocking used to void warranty. Nowadays, they have locked all of it and they're just like, okay, we're going to give you the most viable option based on the internal algorithms. Now, that algorithm is supposed to rely on temperature, primarily speaking. So if that part is messed up, it could cook itself without even knowing that it's cooking itself. So that part is not working. We know it's not working, but question is, why? Was there a manufacturing defect? Was there a design defect? We do not know. Now, the consequence of this is this creates a very sloppy problem, meaning it's not like I turn on the computer goes boom, everything is sorted, we know that this went to boom. It's not that. Silicon degradation is a very random event, meaning let's say this part got cooked, then this part got cooked. Okay, what will happen? That's the problem. We do not know. You could literally have a computer that is damaged. It's working fine, everything is dandy, you shut it off, turn it on again. It's like, okay, now I'm glitchy. Now you turn it off, turn it on again. It's like, I'm good, I got this. That's called silicon degradation. Now again, to call something silicon degradation, you have to be damn sure you have double checked, quadruple checked everything else, specifically the software. That's why we know Intel is at fault, because it's happening to servers. So when Linux says that, brah, you messed up, you messed up. So that's happening. That degradation is happening. That's why it's so random. That's why it took people so long. Again, it logically made sense that server may have messed up. And again, if you're getting VRAM error, you will think that it's GPU. But turns out there is a serious silicon degradation. That's why the brand new CPUs were like, we good. But over a few months, it's like, I can't do this anymore. And people are like, what the hell happened? Silicon degradation. And what does that mean? Degradation part, that's the worst thing of this. Meaning that means if you have the CPU and if it's not pre-damaged yet, meaning if you have been running it for a few months, it most likely it's pre-damaged. If you haven't, like let's say you just bought it, you installed it yesterday, unless you have the latest and greatest and most verified BIOS setting, yeah, there is a serious chance you will cook your CPU. It's not stable, meaning you cannot just have this and run a long-term system on this, like especially not anything that is mission critical, as they say. So we have reached that point. This is here, this is real, this is serious issue. So there are some serious causes here. So, okay, so far we have looked into what publics are saying, what newsers are saying, what NVIDIA is saying and all that. What is Intel doing? Well, Intel, you have to understand, somehow they are acting like nothing bad ever happened to them without realizing that bad things are normal. It happens. It's a normal thing. Now, the bad part is how the heck it happened in 2 generations. Now, there are certain theory or hypothesis. Now, hypothesis 1 is very simple. It's like, hey, I think 13th gen was what exactly they were making, but they could not finish the design in time for launch. So they, called a design freeze, launched it. Then they kept working on that 13th, that flagship design itself, polishing and more, improving it as much as they can, and they amped the voltage setting, tested it, verified it. Again, silicon degradation is a time dependent system, meaning if you're testing it for, let's say, 1 month, you will not see an issue. 3 months you will notice an issue. So again, let's say they tested it only for 1 month, which is logical, and they're like, okay, let's package up, this is 14th gen. Now the first 13th gen, because that power capacity was limited, it was not cooking itself very fast. You launch 14 cooks very quickly, and by this time 13th was also cooked. Now that's the guess. That 13th was slow cooking, it reached this point of falling apart. 14th was fast cooking, so it reached this point quickly. And now we have a random scenario where both of them are cooking at the same time in the marketplace. So that's a big issue. That's the best hypothesis I have seen, that why the heck 2 generations are having the same issue. And so what does it what does it say? It simply says the one thing that when I was building my last computer, like around 1.5 years ago, many people are like, why did you not buy Intel? And again, because I live in an area which is very ugly power, we have very ugly power, voltage fluctuations to like flat out blackouts for hours per day. So I needed a system that could run, that could be run reliably on either solar or batteries or something like that. So I wanted to be damn sure about energy efficiency. AMD is giving power to performance ratio on an exponentially better level. And while I'm comparing it to similar kind of prices, like, okay, AMD X price, Intel X price, comparing that energy consumption, it's like, what the hell? And you're like, okay, it can do more. No. Like if you take a video file, okay, let's say you take a video file, render that file. Let's say AMD is consuming 1 unit of electrical power. Intel was consuming 1.5 to 3. It was way too power inefficient. So what does it show? And given the fact that Intel is now known for consuming 400 watts, 500 watts, and everybody is testing it for overclocking, that's a very bad sign. That means the only way they can achieve this sort of bonkers power is by overcooking it. Basically, this puppy flew too close to the sun and it got burnt. As simple as that. It's like too close. They were like, silicon is this good? They're like, what if I... And they were just like, that cooked it basically. So getting performance by roasting the CPU, it's a very short-term trick. And that's why I said like 13th generation now coming home to roost. And people are like, and be mindful, many people have gotten their, new CPUs and they put it in the motherboard, and that was also fried. So that happened. So now like, okay, what can Intel do? Well, Intel is, after lot of saying, oh, we do not care, it's your fault or it's their fault, they finally admitted that there is something and they are investigating. But all the band-aid, so to say, that has been applied right now, all the basically mitigation strategies, it reduces your performance. And that is a fundamental pissing off your customer, because whoever bought this, let's say i9 or 4900K or whatever have you, they were expecting GG performance, and now you are downgrading the performance by 10 or 20%. They're like, I would have bought AMD, man, and I would have saved so much electricity, man. So that's a very serious bitch slap to the customer. And be mindful, the people do not mind bad things happening. It happens. The opaqueness, the fact that they were not communicating, the fact they were blaming other parties before they were like, okay, let me investigate, let me figure out what's wrong. They're like, no, it's this fault. Oh, no, that's fault. It's like, bro, it's your fault. So that kind of pissed off people. And this has happened not only once, many times. So we'll discuss more. Now, let's understand a contrast, right? You can say that this person did bad. How do you know other company would have done better? We have the example, AMD. Now, AMD released a new puppy that was AMD Ryzen 7 7800X. Now, 7000 series, I have that same CPU. They have a 3D Vcache variant. Now, when the 5000 got the 3D Vcache variant, because 3D Vcache is completely different, like physically different architecture compared to the old system, they were like very conservative with it. Like, we will not let you roast this puppy, so overclocking was limited. Now, any cache sensitive application and in games and all that, they were flying, but they were like, okay, the bulk performance was limited simply because, again, they did not want to cook it. But when they released 7000 series, they're like, okay, this is Mark II variant, we are a bit more comfortable with it, so they give a bit more leeway to the motherboard vendors. It's like, hey, go YOLO on it. Be mindful, modern systems have a feedback loop where the processor literally studies itself, figures out its temperature, and then asks for more power. Now, there has to be communication limitation, where it's like CPU can go YOLO on it, but again, if you change the physical structure, it may be like, hey, I do not actually have sensors like, 7-layer or top of me, or bottom layer could be fried, but the top layer is reading normal. So you have to program it while you're building the chip. So there was a lot of confusion. It was actually exploding. This was the first time people actually, hey, it went boom. It dented my motherboard. So that happened. This happened. This is a real thing. It happened just a year ago or so. So there was a lot of confusion, a lot of anger. However, AMD came out quite quickly where it's like, what the hell is happening? So AMD was like, hey, SoC voltage is being overcooked. So after that, what happened? What actually happened was AMD was doing the same thing Intel is doing, but AMD actually acknowledged it and fixed it, is that there was a miscommunication. The love-making session that's supposed to happen between motherboard makers and basically the CPUs, they were not done properly. So the motherboard engineers, they were overcooking without realizing, because the spec sheet they got was very generous, so to say. And that's why it was limited to this X3D variant. You would not hear like this thing happen to all other systems, because again, those were very well tested, refined, absolute. 3D variant was like, hey, voltage, bro. So that happened. Now, there was a communication breakdown. AMD did that, and a lot of BIOS updates were done, quickly fixing it. And a lot of RMAs also had to be done. And we went through it. Even though we had a company known as Asus, which unfortunately I have the GPU and motherboard from Asus only, they actually was like, what if we F the customer, So this is what they really, Asus does not give any warranty or whatever, what is that? Yeah, whether express or limited to substitute compatible usability of UEFI BIOS firmware as any of its content. Basically, they were like, hey, if you update the BIOS to save your precious CPU, we're gonna void your warranty. Lot of bit slapping happened. A lot of people were like, enough loud people started to actually make noise that were like, whoa, 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 okay. And I'm not joking. This is the thing that I've heard. A lot of OEMs were using MSI simply because MSI's REM, warranty policies are actually far more reliable, usable. So Asus was in a point where they're like, if we keep pissing off, there is a serious chance people could jump to other companies. So they're like, okay, let's fix it. So even with that, let that be very clear. Asus was just like, what if we piss on the customer? They did that. Even then, AMD and all the community got together and fixed it. And why did it happen? Because AMD was very transparent with it. It's like, this is what happened. First, they were like, no, it's the motherboard. They're like, okay, we messed up. Okay, we messed up. But all of these things were done, clear, sorted. You might not even remember it that it happened only 1 year ago, simply because communication was clear. Compared to Intel, let that be very clear. This was not perfect. But compared to Intel, this is like, whoo. So what can we expect in the future? Well, reality is Intel is in a bad spot. Now be mindful, Intel had been like king for decades. There was like Intel and everybody else. Basically, how you have NVIDIA and everybody else, that was Intel. So unfortunately, they are not in that same position anymore. And their sales rates are going down, meaning how many desktops they are covering, that is slowly. AMD is basically tick, 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 tick. Now, so far there was like, that's $1 billion loss. Who gives a damn? We have hundreds of $1 billion in servers. Who cares? Yeah, Apex cares. Apex starting to. Now the share percentage is like Intel and everybody else is like Intel and AMD. It's like, what the hell happened? So let that be very clear. This is a big deal. And how big deal it is? Well, Intel is like, hey, what if we offer the fabrication facilities that we have built? Be mindful, there is only 2 major companies that I know of. That is Samsung and TSMC that can go to like, flagship level. Intel is like, what if we offer that services? So no company would do that if they were not like, feeling the pressure. So they are feeling the pressure. So we know they are feeling the pressure. And all those things are like, eesh, that's affecting it. And consequences, they had way too many failures way too recently, meaning less than 10 to 15 years ago, they already had melted down. Spectre. Now, all of these were like they were developing a branch predictor algorithm that created a backdoor. Somebody can go buy it. And to fix it, they had to upgrade it. Now, when they upgraded it, it downgraded the performance by as much as 5% to 9%. Again, people went back to the same thing. It's like, what's the point of buying your flagships if it's not fast? So that was an issue. And after that, the 14 plus plus meme happened. 14 nanometers, they're like 14 nanometers plus plus, 14 nanometer plus plus plus. Basically, their hardware team was not able to, truly innovate as they were expecting it to. So deadlines were being trolled and production launch being sure. Be mindful, the same thing has happened with TSMC and Samsung also. So it's not like, oh, it's only new to Intel. But it, again, you already had this. This is like, affecting basically perception, and perception affects the stock market. So be mindful, it is a big deal that these sort of things are happening one after another. And then you just fried your 13th gen and 14th gen, both of them having this. And what Intel was trying to do, which most company figured out, is that in case of AMD kind of stuck, because it's like they launched it and processor blew up, so they had to fix it in it. What Intel got is like slow burn, and they were like, if we just waited few months, people will get bored, people have TikTok attention span, and then we release 15th gen, nobody will talk about this. So, but that kind of backfiring right now. So that's a very serious issue. Now, the biggest issue they have is AMD 5000. Now, the reason is this is the first time ever there is like, buy AMD, the end. Now, be mindful, right now there is again competition, but again, competition is coming at the cost of frying your CPUs. So people are like, ooh, that's not a tough pill, basically not an easy pill to swallow. So that changed the game. That actually made a scenario where it's like, hey, remember the bulldozer days? I have bulldozer. So like bulldozer day was like, don't buy room heater, buy bulldozer. So that changed. And again, I am running my computer on solar. I know it's efficient, even though my power supply is ludicrously overpowered. So that's a big issue. That's sort of like, paradigm shift, where it's like everybody is comparing, Intel, and everybody's like, let's overclock it. Let's test the cooling system. Why they're using Intel? Yeah, it fries up like 400 watts of power. It's like, are you kidding me? My whole setup that you are seeing is less than 400 watts from the wall at this point in time. So that's a very serious issue, bad timing basically. So basically, unless Intel does something really good and really quickly and for long enough, they may just go into a point where it's like, hope our fabrication business does well. So the boom happened, that debacle that happened right now, it's bad for them. Like, it's actually bad. Be mindful, at some point, IBM was the daddy. Now it just became granddaddy that is buried somewhere. So be mindful, bigger companies are, compared to Intel, have risen and fallen. So they really need to get their act together. And if the rumors are 55% true of AMD 9000, yeah, they're going to have some hard time trying to capture back. And all they have to make sure is not to blow up. So this was my presentation on basically what the hell happened with Intel. Hopefully this has clarified it. In that case, please click the like button, share it amongst friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.